acid, bases, and let's see their learning outcomes. So very first learning outcome is we are going to define acids, bases, and salts, including their characteristic properties. So when I talk about characteristic properties, I have meant it to be what we can see it in our world, the surroundings around us, not what we are going to read in the book. And when I teach chemistry, I particularly tell students that nothing is written in the books, nothing is pre-written. Everything is examined, tested, researched, analyzed, and then it's written in your books. So every time whenever you are studying, don't consider it कि ये हमेशा से ही books में है. First it was observed, and same with these properties were observed first, then they were tested, and then they were analyzed, and then they are written in the books for a further information. And along with it, we are going to see the chemical reactions of acid, bases, and salts. Second learning outcome is students can differentiate between acids and bases on the basis of indicators, especially the natural indicators, because when we talk about key, we are going to see around. So natural things are the priority. Third one is identifying the common examples of acids and bases and salts in our household products and in everyday life, and how they are helping us or destroying something in environment or making it good for living. Fourth one is explaining the concept of pH and its significance in determining the strength of acid and bases. This is a little bit typical question of chemistry. So once we will go through the basics, then I'll come back to this outcome. And fourth, last one is the effect of acid and bases in human body. These are the basic outcomes that I want my students to learn first, and then they will move to typical professional chemistry. So let's relate it with what they already know about chemistry. So chemistry, physics, biology, we divided our science into these three subparts in class 9th itself. In class 9th, we introduced them. Okay, now you have three subjects, physics, chemistry, and biology. And in chemistry, we have very first chapter, matter. I always try to relate my chapters in a story streamlined. Like what they have studied in 7th, I take it to the 8th, and then I relate it with them so that it will be a reminder to them as well, and it will be a streamlined knowledge. So in 9th class, the very first chapter is matter in our surrounding. So in matter, when I used to teach them matter, it's like everything that is around you. And when you see everything, there are different forms of that everything. Something is very hard as solid, something is fluid as liquid, and gases, obviously, that is not visible, but we can feel it. So very first differentiation of matter they have studied in class 9th is solids, liquids, and gases. On what basis we differentiate it? We saw solid, we cannot break it. We saw liquid, we can easily move our hand in it. And then the gases, it's a very easy flowy thing. So on the basis of space between the particles, on the basis of interaction or the force between the particles, and the fluidity in the medium, some other is the compressibility, rigidity. We all know about these things because this is something very basic we have learned. So how they will correlate? They started their knowledge with the matter. Everything is around them. And then they differentiated it because solid, they cannot break easily. Liquid, they can break it pretty much easily. So why differentiation is important? In this particular part, we used to teach them, or like we take it their knowledge, like why differentiation is important. Any one of you can answer why we differentiate things. Saw them as it is, study them as it is, why we have divided solids, liquids, and gases, why we have in geography divided the continents and studying them differently, why differentiation is important. Any one of you? In your particular subject, you can think of anything. Why we differentiate?
To study their properties.
To basically study the things easily, to do research work easily. If everything is solid around us, so it will be something common in between them. So for study, for knowledge, for research work, we do differentiation ताकि एक चीज को जानना हमारे लिए थोड़ा सा आसान हो जाए. Similarly, when they enter to class 10th, we are differentiating the same substances, same matter on the chemical properties basically. So acids, bases, and salts is another differentiation of matter that we used to teach them in class 10th on the basis of chemical changes brought by matter present around us. Let's see what chemical changes or what kind of different properties we are talking about. So the very first thing that we see around us is the color of a thing that attracts us, that makes us to notice a particular thing. So when we talk about acids, they are generally colorless. And when we talk about bases, they are also colorless, but except few of them. I'm not going to take up this typical name hydroxides of iron and copper right now. Later we will talk about it. And when we talk about mineral acids and when we tell them about organic acids, they might co-relate it with what are mineral acids. Mineral word बहुत हमेशा से हम EVS में पढ़ते आए हैं. Later on it enters into the social science world. So through this we can relate it mineral acids कहाँ से मिलते हैं. Mineral deposits से मिलते हैं या हमें किसी और sources से मिलते हैं. They can relate their knowledge from science to social science as well. Then second thing, after visualizing something around us, next thing we try to touch it. Like when we touch it, how we are going to feel it. It is soft, it is burning, it is slippery, what it's kind. So acids are generally corrosive in nature to touch and bases are slippery like a soap. So what is the meaning of corrosive? A journal English meaning. Any one of you? What is you understand by the word corrosive?
Harmful. It may burn the skin.
Which harm your skin. Our skin is very sensitive. It burns very easily. So corrosive means which burn your skin, which harm your skin. So acids generally burn your skin and bases are slippery like your soap. And next is after seeing it, after touching it, our third sense acts, which is taste. We always try to taste. So acids are sour in taste and bases are bitter in taste. Fourth one is a little bit chemical property, which is the solubility in water. So acids are soluble in water. Some bases are soluble in water and we used to give them a very special name, alkalis. So alkalis are those bases which are soluble in water, but all bases are not soluble. Here are few acids which are present around us. So most of you have known these acids or basically these resources which are sour in taste. Number one is vinegar, which is having a acetic acid. These names, acetic acid, citric acid, they are the chemical names. Next is orange, which is having a citric acid. Next is tamarind, which is having a tartaric acid. Next, tomato, oxalic acid. Curd, lactic acid. Lemon, citric acid. And sting, methanoic acid, which irritates your skin. Nettle sting, methanoic acid. Nettle is basically a wild plant which irritates the skin. So can I ask one thing, like vinegar is a man-made thing or it is a naturally obtained? Vinegar and how it is obtained? A very journal thing, we all are using vinegar at home. Nowadays, apple cider vinegar is very famous. So vinegar is something natural or something processed? Better I would use the word. I mentioned them in the natural acids. Any one of you, it's a natural or it's a processed vinegar?
I think it's natural, ma'am. It is
Yeah, it's
microorganisms are used in making vinegar.
Right.
As far as I know.
So vinegar is a natural acid because it's formed by various fruits by fermenting it. and then we reach to the stage where that water becomes a little sour in taste, and that turns out to be a vinegar. So vinegar is a natural thing. Few students have asked me, ma'am, vinegar seems to be a very scientific word, जो lab में बनता होगा शायद. नहीं, vinegar is formed at, you can make a vinegar at your home with various fruits also. Okay, next, some of the natural sources of bases. Number one is ammonia, which is used in a cleaning products or the decomposition of matter. We have so many times heard about ki somewhere decomposition of matter was taking place and a gas was getting evolved. So ammonia is one of the component. Next is the sodium bicarbonate, which is also known as baking soda. Each one of you is having in your kitchen. And this is found in the mineral springs and some natural mineral deposits. Again, mineral deposits came here, they again correlate to the social science using their maps where the mineral deposits are present in the world. So it can be interdisciplinary work also. Third is magnesium hydroxide. Again, it's found in the mineral deposits and it's used in an antacid. Can any one of you tell me what is antacids? You might have it in your home right now. Antacids.
Digen.
Sorry?
Digen.
Digen, right. Something which is opposite to acid, which kills the acidity. So antacids are those things. Magnesium hydroxide is very famous antacids. Next is calcium carbonate, which is found in limestones, shell of marine organisms, and eggshells. And the last one is potassium hydroxides, which are found in some plants and in the production of soap. These are very basic examples that students can correlate with. Next, we have, like, when we are talking about the uses and the natural sources of our acids and bases, then comes how we can test them. Like, what are the sources which we use, which we can use, okay, this particular substance is acid or having an acid, or this particular substance is base. Because we cannot touch everything, it might hurt us. And we cannot taste everything, it might be poisonous. So here we have a next topic of the chapter, which is indicators. Indicators, journal meaning that's something which indicates us something. Indicate means it gives us some result or some signal about a particular thing. So in chemistry, in this particular topic, indicators tells whether a substance is acidic or basic by showing the change in color or odor. I hope you all are very familiar with odor. It's a smell. So we have three types of indicators. We are talking about natural things. So natural indicators. Next is synthetic, which are lab-made. And third one is olfactory indicators, which related to your smell, your sense of smell. So when we talk about natural indicators, in basic, we have three indicators: litmus, turmeric, and hibiscus tea or China roast. Synthetic indicators, we have methyl orange, we have phenolphthalein, and in olfactory indicators, we have vanilla and onion, vanilla essence basically, because they both are having very sharp smell, and onion smell. So let's see some videos of their test, then we will come back to the result.
Have you started with the video?
So ma'am,
Okay, fine.
I'm sharing a separate screen. Now I have started it. It's just getting started. Or more excited to perform a series of tests on a few solutions.
The video is not visible. It has not played.
I think now it's visible.
Use yellow colored paper strips, and before you could return to guide them, then had already dropped a few drops of some solution on it.
No, ma'am, not yet.
Surprise! Paper turned bright red.
You can't see?
Oops, Sarah,
No, ma'am.
and then
It is not visible.
magic.
Wait.
How did the paper turn red? The teacher returned and explained that the two had performed.
It was not visible.
No, we cannot see anything.
Okay.
Rana and Zen were all excited to perform a series of tests on a few solutions. To
Is it
find out
visible now?
No,
whether
ma'am. Still not. It is not visible.
the teacher handed a few yellow-colored paper strips, and before he could return to guide them, Zen had
Let's get back to the screen then. Okay. This is fine. You can see the PPT again.
Not yet. Not yet. We are still on the screen of the videos only.
Wait, I'll reshare. Okay, so here are the results of all the, now you can see the screen.
Yes, ma'am. It's visible now.
Okay, so here are the results of all related indicators. The very first one is the litmus. So litmus comes from the word lichens, Lichens. How many of you have heard about it, the word lichen? It's from 6th class science. Biology teachers, what are lichens? Through these questions, we can like recapitulate students' previous knowledge. Lichens.
Ma'am, symbiotic association of algae and fungus.
Right. So symbiotic association of algae and fungus. So there is fungus, there is algae. They used to live together to share their food and shelter. It's a biological thing. So in those particular symbiotic relationship, a lichen gives a secretion that turns blue litmus red and turns red litmus blue with acids and bases respectively. So acids give red color with litmus and bases give blue color with litmus. Next is turmeric. Each one of us is having a turmeric, and when turmeric stain got on clothes, we used to wash it with soap, right? So it turns red. How many of you are agree to it? You can give the thumbs up that it turns red with you. If you have a thumbs up. Turmeric turns bases red and there is no change in color with the acids. Third one is the hibiscus tea, which is your China rose also. Blue changes to red and there is no change with the bases. And with vanilla and onion, this is something we have already experienced it in our daily life. Then when we used to eat onion or like our hands got smelly after cutting onion, we used to wash it with our soap or we used to brush our teeth. So the smell goes away. Our soap, our toothpaste, each one of them are having base. So onion and vanilla essence, they lose their smell with base, but there is no change in smell with the acids. Next is methyl orange. It turned red in the presence of acid and it turned yellow in the presence of base. Phenolphthalein, which is a colorless liquid, it remains colorless in the presence of acid and turns pink in the presence of base. And very famous indicator that is being used in class 11th and 12th for the indicating test or the titration test. So these are the indicators which indicates us, okay, this particular substance is acid and this particular substance is base without touching or tasting them. So now through these indicators, students can conclude or we can conclude that, okay, this substance is having an acid and this substance is having a base. Any one of you is having any particular experience about these indicators in your daily life, you can share. Anything? So natural indicators, we have discussed 3. Synthetic indicators, we have discussed these 2. And for olfactory indicators, we have discussed vanilla and honey. So we can conclude, or we can tell the students now to conclude about the properties of acids. Instead of telling them in the starting about everything, we can first show them the results. We can make them to touch and taste some natural acids, and then they can themselves conclude the properties of acids. So they taste sour, and the word comes from acid, which is a Latin word acer. They turn blue litmus red, and in aqueous solution of an acid, they conduct electric current also. What is aqueous solution? It's a solution with water. And acids reacts with bases to form salt and water. We'll come back to this fourth point later in the. So what are the uses of acids? What are the daily uses of acids? HCl in our stomach, ethanoic acid in food industry, sulfuric acid in the batteries, fatty acids in your soap, nitric acid in the ammonia fertilizer manufacturing, and carbonic acid in your aerated drinks. And similarly, we can conclude the properties of bases also. Bases, they taste better. They are slippery and soapy to touch. They turn red litmus blue. Their aqueous solution also conducts electricity. And bases reacts with acid to form salt and water. It's a vice versa. And now, after completing this particular part, we can ask the student to define acid and base. First, they will remember few information, then they will try to understand and apply that in their surrounding, and then they will analyze that information. And after evaluating, they will create the definition, they will find the uses, something else which I have not mentioned. And at the end of the class, let them to prepare an exit ticket of the lecture. What is exit ticket? Exit ticket is basically a small slip on which they can write what they have understood in the class. Let me show you some exit tickets that my students have prepared on this topic. In every particular class, it usually takes 5 minutes of the ending class that they just write what they have understood. It can be wrong, it can be right, it can be anything what they have understood. Let me show you few exit tickets. Can you see me? See, these are small tickets. These are small papers. Some have decorated it really well also. They used to write it in their notebook as well. Today I took it. These are their exit tickets. So we can give it to them at the end of every single class, what they have written. Like the student has made 4 exit tickets on each particular topic. So this can be the reflection of your class and reflection of what you have taught and what they have understood. Because we are not telling them to write everything correct. It's their first time of listening the chapter. It's their first time of understanding the things. So let them go. Write what they want to write. And while they are writing, we can take a round and we can just check it out, what they are doing. We can correct it if they are going wrong. So this is how we can do the reflection and reinforcement of the topic on a daily class in last 5 minutes. It takes less than 5 minutes sometimes. So let's move to the topic further. Now there comes the classification. Once we classified substances into acids and bases, now we are classifying further acids and bases into something else. So first classification is on the basis of concentration, which is concentrated acids or concentrated bases. Second is diluted acids and diluted bases. Third one is on the basis of, second classification is on the basis of strength, strong acids or strong bases, weak acids or weak bases. So what is the journal meaning of the word concentration? We use it on our daily life. What is the meaning of the word concentration? Other than having a concentration of listening this lecture. Like we are concentrated to listen this lecture. We are concentrated on doing this work. What is the journal meaning? Any one of you? You can start your mic.
Excuse me, ma'am.
Yeah.
Yeah, concentration of an acid, it tells us about the amount of water present in an acid. And it doesn't tell the strength of an acid.
Right. So concentration means like how much amount of water is in there in your solution or in the liquid which you are having. If the concentration is more, it means the amount of water is less. It's a pure form of that particular substance. And if you add water into it, it means you are diluting it. You are making the effect of acid a little bit less sour, a little bit less corrosive. So when you want to eliminate or decrease the effect of an acid and bases, just pour water in it. And next is on the basis of strength. Strength is how strong an acid is, how strong a base is, and how weak that particular an acid and how weak that base is. In this, we can take an example, lemon. We can easily have a lemon juice. We can easily drink orange. We can easily add vinegar to our food, but we cannot add HCl to our food, right? We sometimes feel indigestion. There is some burning sensation in our stomach because of excess production of HCl. So by this comparison, we can think that HCl is a strong acid. It's having high power of corrosiveness. And lemon, which is having a citric acid, is not that strong. It can be considered as a weak acid. Same thing can apply to the bases, concentrated bases which are having a more base but less amount of water, and diluted bases which are having more amount of water. Same with the strength of bases. So concentrated acids or bases are those in which the amount of other solute water is less. They are generally pure. Like concentrated hydrochloric acid, even if we will add water in the hydrochloric acid or acid in a white water, so it will have concentrated form and then the diluted one. Strong bases or acids are those which get completely ionized in water. That means they form H positive and OH negative ions in water. Diluted acids are those which get partially ionized in water. That means they do not get completely dissociate to form the ions. Here are some examples. Strong acids, your sulfuric acid, hydrochloric acid, hydrobromic acid, hydroiodic acid, nitric acid, and perchloric acid. So if you can see, there is something common in those strong acids, that is H, hydrogen. H is hydrogen, S is sulfur for all those known chemistry, O is oxygen, Cl, C is capital, chlorine, Br is bromine, I is iodine, N is nitrogen. And the C is carbon itself in the weak acids. So when we see in the strong acids, there is H common in all of them. No doubt, there are in weak acids also there is a H common. But when I talked about they dissociate into H positive and OH negative ions, in strong acids, they usually dissociate easily. Like HCl easily gets break down into H positive and Cl negative ions. Whereas in weak acids, it's difficult or they don't break it into ionic form. Similarly, here we have few examples of strong bases and weak bases. And if you can see, there is one word common in the strong bases, that are hydroxide, hydroxide, hydroxide. Hydroxide is OH, hydro water or hydrogen, and oxide is oxygen. So you can easily correlate hydroxide, hydrogen, and oxygen, that is OH. So they are your strong bases. And then we have weak bases, ammonia. We just saw the examples that ammonia is present in our decomposition of matter, then methylamine, and then pyridine and ammonium hydroxide. Now, what are the chemical properties of acids and bases? Till this point, this is a very journal information that I believe each one of us or each one human should have, because it's on a daily basis. Now we can reach to the chemical properties. Here we are going to take our knowledge to a next level, or the students can take it to the laboratory to do these reactions and researches on the basis of chemical properties of acids and bases. So the reaction of acids and bases with metals, we will observe how they are going to behave with the metal. Second one is the reaction of carbonates and bicarbonates with acids. Carbonates are something which is having carbon and oxygen. The reaction of non-metallic oxides with base, non-metallic, which is having a non-metals and oxygen, and reaction of metallic oxides with acid, and the reaction of acids and bases. So here is the first reaction, acids and bases with metals. So in the very first reaction, the metal in this reaction, which is having metal, is magnesium. Mg is magnesium, and the S in the bracket indicates that it exists in a solid form. Whatever is written in the bracket in the reaction mentioned here is the state of that particular thing which we are going to use to perform our reaction. So magnesium is a metal which is present in a solid form, is getting reacted with the hydrochloric acid, which is an aqueous state. Aqueous, what was aqueous? We talked about it earlier. What's aqueous?
Liquid form.
Liquid form,
Having
basically it is dissolved in metal. Good. So when metal is getting reacted with the acid, it's going to form a salt and release of hydrogen gas. So salt, we are going to talk about salt later as well, but you can correlate salt is having a metal. So metal with acids is going to give you salt and hydrogen gas. Similarly, bases with metal, NaOH with zinc is also going to give you salt and hydrogen gas. Can any one of you tell something about hydrogen gas? Anything you know about hydrogen gas? Anything? Hydrogen gas is a rocket fuel. This is a general information that we can use. It's a rocket fuel. When it burns, it gives immense amount of energy. And it's a lightweight gas. It's a water insoluble gas. So this is how we can give extra knowledge to student irrespective it's there in topic or not. So hydrogen is lightweight, water insoluble and explosive gas. And that's why it is getting used as a rocket fuel, because it gives a lots of amount of energy. Next is how the acids reacts with metal carbonates and bicarbonates. So carbonate is carbon and oxygen. Bicarbonates is hydrogen, carbon and oxygen. You can see there in the reaction. Reaction number 1, which is Na sodium, CO3 is carbon. So sodium carbonate, or better I will use the word metal carbonate, reacts with HCl, hydrochloric acid, to form a salt, NaCl. NaCl, any one of you know which salt is this? NaCl. You have this in your kitchen. This is common salt.
Table salt.
Yeah,
Salt, common
Table
salt.
salt.
It's a
Common
common
salt.
table salt. So NaCl, you will get NaCl. From that carbonate part, CO3, you will get carbon dioxide gas and water as a result. Again, their states are mentioned. Next, in your sodium bicarbonate, we have with HCl, again, you will get NaCl, carbon dioxide gas and water. Any one of you can tell the properties of carbon dioxide gas like we have done for hydrogen gas? You can correlate the same properties. Like I have told you, they are hydrogen gas is explosive. So think about carbon dioxide. Is it explosive? You know about it. You just need to find it out. Carbon dioxide is explosive or not?
Not.
No. Can
How
you give
can
me?
it be explosive? We use it in fire extinguishers.
Yeah, we used to use it as a fire extinguisher. We used to blow candles on our birthdays through using this gas only. So carbon dioxide is used to extinguish the fire. So this can be used as a test for carbon dioxide gas. If it extinguishes the burning candle, it means that gas getting evolved out of our reaction is a carbon dioxide gas. Any one of you can tell me the difference between the two reactions, or the difference between the products of the two reactions? Both are having NaCl, both are having carbon dioxide, both are having water. What is the difference? or they are same? They are same. If they are same, then tell no, it's same. If they are different, then you can also tell they are different. Actually, they are different. How they are different? If you can see in the first reaction, it's written 2HCl, which is giving us 2NaCl. And in the next reaction, they are giving us a less amount of molecules. Through same way, we can recapitulate their information that they have learned in chapter 1 of the same class of balancing the equation. They can balance the equation. They can learn balancing the equation in the same chapter also. So there will be a revision of first chapter in the second chapter. So bases do not react with metal carbonates and bicarbonates. So this property is eliminated for bases. Next, we have metallic oxides with acids. When we talk about metallic oxides, it's metal and oxygen. We have metals around us. It's everywhere around us. We are using it for furniture. We are using it for equipment. They get easily react with oxygen present in our environment. And that's what we call corrosion. So they are basic in nature. They act as base when they react with oxygen. So we need to make them react with the acid to observe some change. So when metal oxide, which is basic in nature, reacts with acid like HCl, then it forms salt and water. Please go through this reaction very carefully. I'm going to ask you later a result on it. That basic thing is getting reacted with acid thing to form salt and water. This is the result. Next is non-metallic oxide, non-metal with oxygen. They are opposite. They are acidic in nature. So they are going to react with bases. And then they are going to neutralize each other's effect again to form salt and water. If we will see these two reactions, this one and this, the result is same, salt and water. And again, in both the reactions, something acidic is getting reacted with something basic to form salt and water. This is the third part of our topic, salt. So can we conclude how salts are formed? Can we conclude through these two reactions how we can form a salt?
When acids react with bases.
Right. When acids react with bases, they neutralize each other's effect to form salt and water. So that's what we called neutralization reaction, a very important type of reaction in our chapter, where acids, which are showing the red color, and the bases, which is showing the blue color, they react together to give acid, salt and water. This is our neutralization reaction. So what is neutralization reaction? The reaction between an acid and a base to neutralize each other's effect to produce water and salt is known as neutralization reaction. NaOH having OH, hydroxide ion, aqueous in state is a base. HCl, which is having H ion, H positive ion, aqueous in state, reacts to form NaCl, your table salt and water. So any example of neutralization in daily life? Anyone can give any single example. We have talked it earlier. In the bases, I can give you a hint. When we talked about magnesium hydroxide using properties of a
Brushing
example.
our teeth.
Sorry?
Brushing our teeth daily.
Brushing your teeth, right? Okay, like how? How we can say brushing your teeth?
We neutralize the acid present in our teeth with the help of base in the toothpaste.
That is one example. Other than this, very basic example, you are going to experience it in summers very frequently if you don't have good digestion. I gave you a hint again. It's in your digestion itself. When you feel acidity, you used to drink Eno or you used to have Digene. That is the neutralization in daily life. Very basic thing. So before going through all the examples, let's introduce a new indicator, which is a pH. The pH, P should be like small and H should be capital, which is used to measure the concentration of hydrogen ion in a solution. H stands for hydrogen ion itself. So pH is having a range, numeric range from 0 to 14. 0 is the indication of the highest acidic level and 14 is the indication of alkaline level. The in between 7 is a neutral. So value less than pH on the scale represents the acidic solution and value more than 7 on the scale represents the basic solution. As it goes near to the 14, it turns out to be a strong base. As it goes near to the 0, it turns out to be a more acidic nature. This is a journal picture of a pH scale with the color combinations. If the pH is 0, it's a bright red color, which is a sign of a danger also. So if it's a bright red, it's a danger. It means that that thing is going to be very corrosive in nature. So as it's moving from 0 to 7, it comes out to be a water, which is neutral. And then it reaches to 14, which is your drain cleaner, which is having a violet, dark violet color, 14 more base. So we can see that HCl, that acid which we are using in our laboratories, is the acidic part. Then the one in our stomach is having 1 pH, lemon 2, vinegar 3, wine 4, coffee 5, 6, milk. So coffee is a high in pH, acidic in nature. So drink before checking your digestion. Then water, then blood, then baking soda on 9. Milk of magnesia is your Digene. Ammonia, we talked about it earlier. Soap and your bleaches, 12 and 13 respectively, and your drain cleaner. So these color indications are the pH value, because we have a pH as a pH scale or like pH paper strips, pH strips. When we dip it in a particular kind of solution, then they give a particular color. So we match it with the color combination that is provided on the scale and we can tell their pH near to that. So how the students can learn it? As dark red as it is, it's a more acidic. As dark blue it is, it's a more basic. If it's difficult for understanding, then they can learn it in that. Red is a danger color. It's going to be an acidic side. Blue is going to be the basic side. Now pH in everyday life. How much plants and animals are sensitive to the pH? The very first thing, let's talk about the body. Our body works with the range of 7 to 7.8, which is almost a neutral one. And living organisms can survive only in a narrow range of pH also. So when the pH of your rain is less than 5.6, it turns out to be an acidic rain. And when acid rain flows into a river, it lowers the pH of river water also. That affect the life of aquatic animals. So it's better not to have a polluted environment for each one of us around. Can any one of you explain this picture, like how the acid rain is forming? Any one of you can try, just try it. It needs not to be correct 100%. Can you see that? Okay. Can you see the arrow on the right side? It's NO2 and SO2. These are the pollutants in our environment. The clouds. In clouds, we have a water. Then they are reacting with that water and forming H2SO4 and HNO3. They are acids. When acids are present, they are in atmosphere. It rains. It turns out to be an acid rain, which affects us. Acid rain got formed. So it's better to maintain a good environment. Through this, we can have environmental awareness also. Next is when the pH level of the soil changes. When the pH level of soil is above 7, is it going to be acidic or basic? Above 7.
Basic.
Basic. Elements like iron, zinc, copper, boron, phosphorus, manganese also become less available for the absorption by plants, which are good for their growth. So when it reaches above 7, they can't absorb it properly. And low pH, when the pH level is lower than 5.5, aluminium manganese can become highly available to the point of toxicity. And similarly, low pH levels, other elements like nitrogen, calcium, phosphorus, they are also lessened. So it's better to maintain a pH in between acidic and basic. That's a neutral one. Next is our digestion, our digestive system. Our stomach produces HCl, we all know. So during indigestion, it produces too much HCl, which causes pain, irritation. And at that time, we use antacids. We talked about it earlier as well. Who can explain this picture? We have bio teacher here. Who can explain this picture?
The HCl in our stomach,
Sorry?
the HCl that is released in our stomach kill the germs that we eat with the food.
Okay.
Actually, this is about the bacteria which is present in our teeth due to eating sugary particles.
Very right. So when we eat something sugary or when our carbohydrates get digested inside our mouth through our saliva, the bacteria that present there reacts with the food particle to produce an acid. And that acid basically try to decompose our upper layer of teeth, which causes tooth decay. That's why we used to brush before sleeping, and we tell our children to brush before you sleep, so that tooth decay won't start through these bacteria. So tooth decay starts when the pH of your mouth is lower than 5.5, which can only be reached once acid starts getting formed in your mouth. And the upper layer is tooth enamel, which is a crystalline form of calcium phosphate, the hardest substance in the body. It gets corroded below 5.5 pH. Bacteria reacts with it, produces acids, starting the degradation of sugar and with the food particles in our mouth, and then we brush it to clean it. So here we are actually doing the neutralization. Next is the self-defense by animals and plants. Like some plants and some animals used to stink other animals around them to protect them. So few of them are the bee stings. Bee stings leaves an acid which causes us pain and irritation. Using a mild base like baking soda on the stung areas will give us relief, because baking soda is a base and the acid which is releasing, that gives a neutralization reaction again. Again, the stinking of hair of nettle leaves that we saw earlier in the slide also releases the formic acid, which causes a burning sensation. There is another leaf present around that nettle leaf which reduces its effect. So what are the home remedies that we use for the bee sting? What are those, if any one of you can share? Because we very
We
barely
rub soap on the affected area, na?
Sorry?
Soap on the affected area.
Soap on the affected area, again, we are using a base. Sometimes we use
by rubbing it with some iron articles, because they are basic in nature.
Why iron?
Because they are basic in nature. Iron oxides, metal oxides, they are basic in nature. That's why.
Iron is present in atmosphere. Atmosphere is having oxygen from iron oxide, and when we rub it on that bee sting, basically iron oxide, which was basic in nature, getting reacts with the acid of bee sting to relieve us. So we have talked about salt through this. We have talked about neutralization reaction through this. So we can easily conclude the properties of salt now. So salt is something which can show acidic behavior, basic or neutral behavior as well. We will see how acidic and basic. They conduct electricity in molten state or when they are soluble in water. They are hard, they are crystalline, and they are non-volatile in nature. Non-volatile, they cannot evaporate so easily. They have high melting points. They are insoluble in organic solvents like kerosene and petrol. So these were the properties of salts, which are general conclusion. Let's get into something very interesting, effect of acids in your stomach. What is this on the screen? If any one of you can explain. This is something very familiar. Basically, this is the state of our body. Can anyone wants to just comment on it?
3 elements of our body according to Ayurveda.
Yeah, according to Ayurveda, these are the states of our body. Vata, Pitta, Kapha. And Vata, it's a ether and air. It's Pitta, it's a fire and water. And it's Kapha, it's earth and water. So it can be a variable according to our body, our living style, our environment, what we eat, how we inhale it. So when we talk about a particular state of body, it's Pitta. When it's got imbalance and balance, there is a different effect on your body and mind. So when we have Pitta imbalance, we usually get angry, we got impatient, it's very excessively aggression towards achieving the goals. There is loss of intellectual power. We become jealous, arrogant, over competitive. And in our body start producing more heat. There will be a digestive problems. There will be a vision difficulties, inflammation, diarrhea, ulcers. And when it's balanced, it's going to be a very perfect body of strong digestion, goal setting inclinations, focused, confidence, medium body frame, well-framed body features, bright complexion. So how we can maintain it? How we need to maintain it in summers, because summer is the Pitta season and we all are experiencing a summer. So we can have a particular kind of bases in our food. Like we can eat sweet, we can eat bitter things, we can eat astringent things. We can add coriander, cardamom, cumin, which are cooling in nature to maintain this acidic nature of our body, to have all those good things about our body and mind. And for a diet, it's mentioned here. You can see it. So this is how the acids are affecting our body. And further, when it's affecting our body, it's affecting our mind, and it's affecting our mind, it's affecting our life. So let's teach the students how the chemistry is affecting them, their body, their environment, their power to do something. So this is all from my side. Thank you so much, and have a happy, healthy summer. Any one of you want to ask anything from the slide or any particular question? Any question from anyone's side?
No question. No, nobody's asking question.
Any experience of yours you want to share on the topic? Anything you want to tell me about this